Hello everyone, welcome you all to today's class. So today's class is all about vector product. Okay, so while taking product of two vectors, so we have two types of product of vectors involving two vectors. The first one is scalar or dot product of two vectors. Second one is cross or vector product of two vectors. So if we go to three vectors, like we have scalar triple product and vector triple product. But in our syllabus, we are going to cover scalar or dot product of two vectors and cross or vector product of two vectors. So today's class will be on dot or scalar product of two vectors. Okay, so let's begin the class. Okay, so while going to, dot product or scalar product of two vectors, suppose we have A and B, two non-zero vectors. The dot product or scalar product of two vectors A and B denoted by this A dot B is defined as A dot B equal to magnitude of A into magnitude of B into cos theta. Okay, so as we know, magnitude of A is a number, length of the directed line segment. Similarly, magnitude of B is also a number and cos theta is a number lying, the taking the values from -1 to +1. Okay, maximum value of cos theta is 1, minimum value is -1. So this is a number, magnitude of A is a number, magnitude of B is a number, cos theta is also a number. So A dot B is basically product of three numbers. So this is a number. This is a scalar quantity. Okay, so because A dot B is a scalar quantity, the name is scalar product of two vectors. Now, to denote this, we use prominent dot here, A dot B. We can write just like this. Okay, we have to write like this. So, because of the presence of dot, we call it dot product. Okay, so that's why the name dot product or scalar product. Okay, now theta is what? Theta is angle between vector A and vector B, and theta is between 0 to pi. It means it will be either acute angle or obtuse angle. Okay, and also it can be 0, it can be pi also. Okay, now if you have vector A is like this, see the, and vector B, theta is angle between two vectors. So we can have A vector dot B vector equal to magnitude of A into magnitude of B into cos theta. Okay, theta may be acute or obtuse, as I said. Now going to properties of scalar product of two vectors. First of all, A dot B is a scalar quantity. Okay, and when we say A dot B is a scalar quantity, now second point is dot product is commutative. Means A dot B equal to B dot A. Okay, so because if I write here B dot A, I can take magnitude of B into magnitude of A. So if I change the direction also, it will be cos minus theta. And again it is cos minus theta, means it is cos theta. So you are getting here magnitude of A, magnitude of B and A, then it is cos theta. So either you write A into B or B into A. That is same thing. Product of any two numbers, that is commutative. So this is a number, magnitude of B is a number, magnitude of A is a number. So whether you write A, B or B, A, no problem. So A dot B is commutative, dot product is commutative. And also if you take three vectors, A dot B plus C, that is A dot B plus A dot C. It means dot product is distributive over vector addition. Okay, next coming to A dot B, as we know, it is magnitude of A into magnitude of B into cos theta. So this will help us to find angle between two vectors. So cos theta equal to A dot B by magnitude of A into magnitude of B. It means theta equal to cos inverse of this. Okay. So as I said, theta can be acute or obtuse. So in case theta is acute angle, cos theta will be positive. If theta is obtuse angle, cos theta will be negative. So what you can say, so if you have if theta is acute, theta is acute angle. It means whenever we say angle between, I mean if theta is acute angle between A and B, then cos theta we can write like this: A dot B divided by magnitude of A into magnitude of B. Okay. So just to avoid that negative sign, we can write like this. So if in the question nothing is given, so, and simply it is given find angle between A and B. So maybe you can take let theta be the acute angle between A and B. So cos theta equal to this magnitude of A dot B by magnitude of A into magnitude of B. So then you can get theta. Okay, so that is the fourth property. So now coming to fifth property, here is theta equal to 90 degree. So this implies what? Cos theta equal to 0. So this implies A dot B equal to 0. So here we can see when theta 90 degree, angle between A and B 90 degree. So what we can conclude here, A vector perpendicular to B vector, if and only if A dot B equal to 0. Okay, so for two perpendicular vectors, dot product vanishes. Dot product becomes 0. Okay, so going in the same line, what we can conclude, I dot j equal to j dot k equal to k dot I, that will be 0. So because we take x axis, y axis and z axis, they are mutually perpendicular lines. So I cap, j cap, k cap, these are three unit vectors perpendicular to each other. So I dot j equal to 0, j dot k equal to 0, k dot I equal to 0. Okay. And if I write here, suppose for example, for any vector A, if I write A dot A, magnitude of A into magnitude of A into cos 0, cos 0 equal to 1. So you are getting A dot A equal to magnitude of A square. So I dot I equal to magnitude of I square. Square of magnitude of I, that is equal to 1. So j dot j equal to 1, k dot k equal to 1. So I, j, k are unit vectors. Okay. And the sixth property says, yeah, so whenever we are given vectors in component form, suppose for example, you are given A vector is A1i plus B1j plus C1k and B vector is A2i plus B2j plus C2k. Now if I find A dot B, so this is basically A1i plus B1j plus C1k, and we take dot of A2i plus B2j plus C2k. Now when you multiply like A1, A2, I dot I1, so you are getting A1, A2. A1, B2, I dot J0, A1, C2, I dot K0. Now B1, A2, J dot I0, because I, J perpendicular to each other. Now here B1, B2, J dot J1. Similarly, you are getting C1, C2. Okay. So it means whenever you are getting the dot product of two vectors, what we are doing? We are taking sum of the products of the direction ratios. Okay, yeah, scalar components. Right? So for example, if you have a vector is 2I minus 3j plus k. B vector is, so it may be 3I plus j minus 5k. So if I have to find A dot B, so it will be what? 2 into 3, 6 minus 3 into 1, then 1 into minus 5. Okay, so you are getting 6 minus 8, that is minus 2. Okay, so this is A dot B. So this is the way to calculate A dot B when you are given the vectors in component form. So basically it is sum of the products of scalar components of two vectors. Sum of the products of corresponding scalar components. Yeah, you can say corresponding direction ratios. Okay, next one is you can take, so we can cover all the, you can say required concepts in this properties. Yeah, so another way to get, angle between two vectors. So if you have A vector given to you, B vector given to you in the component form, maybe I can take like this: A1I plus B1J plus C1K, and B vector is A2I B2J plus C2K. Okay, so A dot B we know. Okay, and so we know cos theta equal to A dot B by magnitude of A, magnitude of B. So if I take theta is acute angle between two vectors, let me just mention this. Theta acute angle between A and B. So it will be A dot B means A1 A2 plus B1 B2 plus C1 C2 divided by magnitude of A is A1 square B1 square C1 square. You know it? Similarly, A2 square plus B2 square plus C2 square, square root of this. And since I have taken acute angle, so it will be always positive. Cos theta will be greater than equal to 0. Okay. Okay. Now, if A vector perpendicular to B vector, then as we know A dot B 0, so it means A1 A2 plus B1 B2 plus C1 C2 equal to 0. Okay, so if you are given vectors in component forms, so this is the way you can find out, you can check whether the vectors are perpendicular or not. Okay. Okay, so now these are some of the properties of dot product of two vectors. Okay, so next we can say application part. So maybe we will be covering this today, and just one moment. Okay. Okay, the properties we already have applications I mean to take. Applications of dot product. Okay, so whenever I take dot product, I am considering two vectors. So it is by default it is two vectors case. Okay, so first application, as I said, one of the applications like to check whether A vector perpendicular to B vector or not. So if you are given two vectors, to check, you have to prove, you have to verify whether the vectors are perpendicular or not. Okay, so that is one of the applications. So that if it is perpendicular, if the vectors are perpendicular, the dot product will be 0. Second application is, yeah, you can say to find angle between a vector and b vector, right? Acute angle, obtuse angle, everything you can find out. Third one is very important, to find the projection of, to find the projection of, projection and projection vector also. Projection of one vector on another. So it means projection of A on B or B on A. So let me explain this projection part. This is one of the important concept. You can expect questions from this portion in board exam. Yeah, so let me just take, so here, this is, let me take this as B vector. Okay, this is A vector. Okay, so it may be, I can take here O for example. Here O doesn't mean it is origin, it is any point. Okay, B, now this is A, so this vector is A vector. Okay, angle between A and B is theta, and theta is acute angle here. Let me draw a perpendicular. Suppose it is OM. I mean AM is the perpendicular. Okay. Now this length OM, this OM, length of OM, this is projection of A on B. Okay. Now let me take, whenever you have A and B two vectors, you know A dot B equal to magnitude of A into magnitude of B into cos theta, right? So if I write here cos theta, this cos theta will be what? If I consider triangle OAM, this is the right triangle. Here cos theta equal to what? Cos theta is OM. I am not putting vector symbol here. So OM by what? OA. Okay. OM by OA means it is basically vector B. Yeah, I can say magnitude of OM. It's not exactly vector B because vector B means OB vector we have taken. OM is part of OB vector. OM vector. So OM magnitude of B. OA means this is basically magnitude of A. Okay. Now if I write here, suppose this is 1. Yeah. So here one more thing I can take. OM vector is what? Here OM vector is, yeah, so OM vector is A cos theta into magnitude of A. So let me just keep it cos theta only. It is 2. Now from 1 and 2, we can say, yes, A dot B equal to magnitude of A into magnitude of B. Now it is cos theta can be replaced by magnitude of OM divided by this. Okay, so it means you are getting what? So this is cancelled. So you are getting OM, magnitude of OM equal to A dot B divided by magnitude of B. Okay, so magnitude of OM is basically what? It is the projection of A on B. Okay, so now projection of A on B is given by A dot B by magnitude of B. So here we can conclude projection of A vector on B vector is A dot B divided by magnitude of B. So if I say projection of B vector on A vector, so that will be what? This is equal to, you can say B dot A or A dot B, no problem, because A dot B equal to B dot A divided by magnitude of A. Okay. Now here since we have taken magnitude of OM as projection, so it means, and also if you observe right hand side, A dot B is a scalar, magnitude of B is a scalar. So it means, and obviously this is also a scalar. Now projection is basically the length of the line segment OM. Okay, and when AM is perpendicular from, I mean, OA or OB. Okay, but if it is projection vector of A on B. So projection vector of A on B will be what? So it is like, you can say this is a scalar quantity. So projection vector of A on B is, it is basically OM vector. So that is OM vector will be what? Magnitude of OM multiplied by unit vector along OM. It means OM vector is in the direction of B vector. So unit vector along the direction of OM means, if you write here OM cap, it is actually what? OM magnitude of this. So OM cap is basically your B cap. Okay. So projection vector of A on B will be given by what? You can write here A dot B by magnitude of B into B cap. Okay, so this gives you magnitude of the projection and direction is along B, so it is B cap. Is it clear? So while reading the question, be very, very careful whether the question is finding projection or projection vector. Okay, so if it is projection vector, you have to see it has both direction and magnitude. Okay, so this is all about the conceptual part of dot product of two vectors. Okay, so apart from the other things, so specifically, yeah. So if you are very, very clear in these points, so I think dot product is not not very difficult task. So maybe 2-3 questions I will take. Maybe question number 1. Suppose you are given a vector equal to I minus j plus k. B vector is equal to I plus j minus k. Find angle between them. Find angle between A vector and B vector. Okay, so you can write here. So if it is, so nothing is given, angle between them, acute, obtuse, nothing is given. So if I write here, theta is angle between two vectors. Okay, so cos theta is, so you can write here A dot B divided by magnitude of A into magnitude of B. Okay, so that is equal to what? A dot B, 1 into 1 minus 1 into 1, 1 into minus 1 divided by magnitude of A, 1 square plus minus 1 square plus 1 square root 3, and here also you are getting root 3. Okay, so you can get here minus 1 by 3. Okay, so it means theta is cos inverse minus 1 by 3. Okay, so here one thing, suppose you are taking acute angle between A and B. If you write, let theta be the acute angle. So cos theta will be cos, I mean 1 by 3. So theta will be cos inverse 1 by 3. And the other angle, because you have not been asked whether you have to get acute or obtuse. So then in that case, the obtuse angle will be pi minus cos inverse 1 by 3, right? or you may write directly like this because nothing is mentioned in the question. Okay, next one more question. Suppose you are given, yeah, so you are given two vectors A and B. It is from NCERT book. Two vectors A and B, magnitude of two vectors same, and angle between them is angle between A and B is 60 degree. Okay, and you are given A dot B equal to 1 by 2. Question is find the magnitude. Find the magnitude of find the magnitude of the vectors. So two vectors are of same magnitude. So magnitude of the vectors you have to find. So this is a very simple question. Yeah, so we are given, yeah, so theta equal to 60 degree. So cos theta is A dot B divided by magnitude of A into magnitude of B. Cos theta means cos 60 degree. This is equal to A dot B 1 by 2. Now magnitude of A and these two are equal. So you can take square of the magnitude. So here you can have 1 by 2 equal to 1 by 2 by square of magnitude of A. So it means magnitude of A, square of it is 1. So magnitude of A is 1. So that is also magnitude of B. Okay, so like this, no, the simple applications, I think, so this is, if you are very clear in concept, so you can have this, yeah. And one question on projection maybe I can take before I just winding up the class. Okay, question number 3. Find the scalar projection. Just I am writing. Find the projection. Find the projection and projection vector. Projection vector of A vector equal to 2i plus 3j plus 2k on B vector equal to I plus 2j plus k. Okay, so here we can take here the projection of A on B. The projection means scalar projection. Projection vector means vector projection. So here you can write projection of A on B equal to A dot B divided by magnitude of B. So that is equal to A dot B, 2 into 1, 2, 3 into 2, 6, 2 into 1, 2, divided by magnitude of B, 1 plus 4 plus 1. So we are getting here 2 plus 2, 4 plus 6. Yeah, 10 divided by root 6. Okay, this is projection of this. So now next one is, so if you want you can write here, so this can be rationalized. So here my main purpose is not calculation, my main purpose to convey you the concept. So then it can be like 5 by 3, okay, units. This is the projection, scalar projection, basically a simply projection. If it is projection vector of A vector on B vector, that is equal to A dot B by magnitude of B, okay, multiplied by B cap. So here you can have, already we have found out. So if I write here 10 by root 6, okay, already we have calculated, so I don't want to calculate it again. So B cap is magnitude of B divided by, sorry, B by magnitude of B. So it means 10 by root 6, B vector is I plus 2j plus k divided by, it is magnitude of B is root 6. So 10 by 6, that is equal to 5 by 3. Okay, into I plus 2j plus k. Okay, this is projection vector of A on B. So I think with this I have to wind up the class. And thank you so much for being patient, listening patiently. And also, if you like the video, please share with your friends. And also, don't forget to press the like button. And in case you have not subscribed the channel, please do subscribe. And I'm sure today's lesson will be very, very helpful to clear the concepts on dot products. Okay, thank you so much. Thank you once again.